Alright, and welcome to Linear Inverses Practice C. Now number 1 says graph negative 4x plus 6y equals 12 and its inverse to the right. So y'all get a little bit of a trickier one, that's why you only have to do one example. And so the initial problem with this is that we actually can't graph this as it is. So let's just, over here to the right, let's just kind of do some things. Let's say, negative 4x plus 6y is equal to 12. See, I'll give myself a little divider there. And in order to graph this, we want to get the letter y by itself. So we can add 4x to both sides, plus 4x. And at this point, we of course have 6y is equal to 4x plus 12. Now, of course, I'll divide everything by 6. And we're going to wind up, kind of squeeze it in down here. 4 over 6 reduces to 2 over 3x. And 12 divided by 6 is, of course, 2. So let's go ahead and graph f of x. We'll go up 1, 2, put our initial point, and our slope is 2 over 3, so we can go up 1, 2, and to the right 1, 2, 3. Okay, and we can draw our initial line, f of x. Okay, so we have f of x right there. Now, a quick little aside. We know that the line y equals f of x always goes through the origin. I'm sorry, y equals x. Always goes through the origin. It goes up 1, right 1, up 1, right 1. And this, of course, is the line that all inverses are reflected over. So we can see that as this orange line approaches this red line, we could probably expect that our function f inverse of x will actually intersect this orange line on the line y equals x. Okay, now let's go ahead and let's tackle our f inverse of x. Now you really have two options. You could either start from right here and just switch your x and your y, which y'all have not seen so far, or we could start where we have been starting and switch our x and our y. Since you guys are my level C students, let's go ahead and switch it from the standard form if you don't mind. So I see it's negative 4x, so I'm just going to write negative 4y, and it's positive 6y, so I'm going to write positive 6x. Doesn't matter where these are located, you just switch your x and your y. Now from here, I can add 4y to both sides, plus, oh wait, I'm so sorry. Guys, what letter are we trying to get by itself? We are trying to get the letter y by itself. So I will subtract 6x. I will move my x instead of my y. So now I have this, of course, I have negative 4y is equal to negative 6x plus 12. And of course, from here, I can divide everything by negative 4. Now, notice that I'll steal down here into c, and that my y becomes f inverse of x, which of course equals negative 6 divided by negative 4 becomes a positive 3 over 2x, and 12 divided by negative 4 is of course negative 3. So I can go down here, I can go down 1, 2, 3, where my y-intercept is, and of course my slope is 3 over 2, so I go up 1, 2, 3, to the right 2, I hit the x-intercept, I go up 1, 2, 3, and to the right 2, and the way I've graphed it, it kind of looks like this. And you'll notice that if my graphing was perfect, these two lines, of course, intersect on the line y equals x. Okay, so you have your initial function, f of x. You have your inverse function, f inverse of x. Now, letter C is very simple. It says describe the transformation of the slope and the y-intercept. We would just say here that from the orange to the blue, we can see that our y-intercept decreased. And we can see that our slope from the orange, it went from being flatter to being steeper, so you can see that your slope increased, and that's about what you would expect every single time. Okay, now what makes this a level C problem? Well, we are actually going to evaluate f inverse of 64 and f of 64. So I want you to pause the video right now, finish taking your notes, and I'm going to erase everything above letter E just so y'all can see this. Alright, so go ahead, pause it, finish taking your notes. Okay, so the question is f inverse of 64 greater than f of 64? Now, a great way for you to just answer this intuitively is which of these lines, f of x or f inverse of x, notice f inverse of x is our blue line, which one has the greater slope? Since the blue line is already outpacing the orange line here, you would expect that 64, which is way over here, you would expect that, yes, this is probably a true statement. But let's just go ahead and fill it out. Now this dark blue doesn't translate well, so I'm going to switch to a light blue for f inverse of x. Okay, and let's see, so here I write f inverse of 64, which means that I'll actually plug it into my function, which I shouldn't have erased, but that was 3 over 2 parentheses 64, we're just plugging in for x, and then of course minus 3. Now let's just go ahead and do some simple mental math here. 64 divided by 2, that's something you can do, is actually 32, and 32 times 3 is 96. So that's a cool little trick there. You can do 64 divided by 2, 32, and then you can just multiply by what's on top. Okay, so we have 96 times 3 minus 3, and of course we see that f of 64 is equal to 96. Oh, my bad. Shouldn't have written that twice. 96 minus 3, which is 93. And I'll just go ahead and record that down here. F of 64 is equal to 93. Once again, I would pause the video, finish taking notes. Let's go ahead and tackle what we have in the orange. Okay, so let's go ahead and evaluate f of 64. And now we can just go ahead, I would use your calculator for this, 2/3 times 64, because it's going to be a decimal. And that's going to roughly give you 39 point, let's say 67 plus 2. Now from this point we can go ahead and add those two things together. We know that 39 plus 2, we can do that when we're just adding. Doesn't work for subtraction with a decimal, but that will be 41.67. And now we can say, hey, is 93 greater than 41.67? And notice, yeah, that's definitely true. Okay, well, level C students, let's look at part D. This is our final little thing. It says write the domain and range for both f of x and f inverse of x. Now, typically, for anything other than a linear function, these will be different, but this is true for all linear functions, so long as they are not cut up or chopped up. We can say this, because either of these lines, they go forever to the left, and they go forever to the right, we can say that their domain, which I'll abbreviate with a D, is from negative infinity to positive infinity. And we can say that their range, because they go forever down and forever up, will also be from negative infinity to positive infinity. Or you could abbreviate by saying all reals. Alright, there you have it. Good luck, and I'll see you guys at the end of class.